Alright, so today we're going to do 1 hour past paper practice for the electrolysis topic, similar to the way that we did for reaction rate and equilibrium. And after we are done with today's session, the next video will be on acid, bases, and salts. So let's just get started right away. Electroplating steel objects with silver involves a 3-step process. A coating of copper is applied to the object, that's step 1. A coating of nickel is applied to the object, step 2, and step 3 is the coating of silver is applied to the object. A diagram in the apparatus used for step 1 is shown. So here we have our anode, which is our positive electrode. Here we have our cathode, which is our negative electrode. Just a reminder. For anyone who wants to go through the electrolysis chapter before watching this video, you will have the option to click on that at the end of this video. And I will also put it in the link in the description. I'll also put the link in the description below. Alright, and we have our electrolyte, which is copper 2 sulfate. Right, so part 1, the chemical process taking place on the surface of the object is right here. Explain whether this process is oxidation or reduction. We covered this in the video, and this is very important. This is a very common question in all your electrolysis questions. You will always need to either interpret or write down such a half equation. So over here, what you can see is that we have an ion, we have copper 2 plus, and we have these electrons, and after that, our copper does not have a charge. It does not have a charge. So what does that mean? Here we have lost electrons. We have 2 electrons missing over here. Then we have 2 electrons being added and we no longer have a charge. So here there is a gain of electrons. And what is a gain of electrons? That is reduction. For anyone who doesn't remember or has trouble remembering, you can remember the acronym OIL-RIG, and that's oxidation is loss of electrons. Oxidation is loss of electrons, and reduction is gain of electrons. So explain whether this process is oxidation or reduction. They use the word explain, so you cannot simply write reduction. You are going to gain your 1 mark when you say reduction, as it is a gain of electrons. Remember, there's no half marking concept in Cambridge, so if you just write reduction, you're not going to get half a mark, you're not going to get a quarter mark, you're going to lose your entire 1 mark, so make sure you do not give the examiner a chance to do that. Explain why the concentration of copper ions in the electrolyte remains constant throughout step 1. So the reason that it remains constant is because the formation of the Cu2 plus ions is occurring at the same rate as the removal of the Cu2 plus ions. Right. So ions being formed at the anode is the same as the ions being gained at cathode. It's occurring at the same rate. It's occurring at the same speed. So the removal of the formation of Cu2 plus ions is equal to the rate of the removal of Cu2 plus ions. Give 2 changes which would be needed in order to coat nickel onto the object in step 2. So there are 2 conditions that we discussed for electroplating, and that is that 1, your electrolyte needs to be the metal, needs to be a salt of the metal that you want electroplated, or you want to plate onto the object. So first of all, you're going to have to change the electrolyte. You can no longer have copper sulfate. You're going to have nickel sulfate. Change electrolyte to nickel sulfate. That's the first thing. And the second change is, if you're going to plate nickel, then there really is no point to have copper as the anode. Why would you do that? You need the metal that needs to be plated on the anode, and the object is on the cathode. So the metal that you want plated is nickel, so you're going to change the anode to nickel. Replace copper anode with nickel. 2 changes, 2 marks. Copper, nickel, and silver are transition metals. Typical physical properties of transition metals are a high density and a high melting point. Give 3 different properties of transition metals which are not typical of other metals. We have not covered this in the videos that I have released so far. So I will not be solving this right now. However, for anyone's information, transition metals have 3 distinct properties, and that is that they are catalysts, they have variable oxidation states, and they form colored compounds. So we have not covered this, but I did answer it over here because this is really only 3 main facts that you need to remember. It's purely memorization. There is no logic that goes into it. It's simply that transition metals, which are in group 2, they have 3 distinct properties, something that makes them different from the rest of the metals, and those 3 properties are catalysts, variable oxidation states, and form colored compounds. We will go through this entire chapter in detail in any of the future videos, inshallah. Okay, so aluminum is extracted by the electrolysis of a molten mixture which contains aluminium oxide. This decomposes to form aluminium at the negative electrode and oxygen at the positive electrode. Write an ionic equation for the reaction at the negative electrode. So the negative electrode is cathode. And at cathode, there is reduction. Always remember this. Anode has oxidation. Anode, oxidation, cathode, reduction. Okay, so we know that if this is reduction, then there is a gain of electrons. So let me see if I can select this over here. Is it possible? No. Right. But point is, if we just take this as an example, I'm going to put it down there so we can compare and contrast. Cu2 plus 2e minus gives Cu. This is a reduction equation, and we now need one for aluminum. Now we know that there's a gain of electrons, so we know that at this end of the arrow we'll have the normal element because it would have gained electrons, right? And we know at this side of the arrow it's going to have its ion because, once again, the electrons are being gained by the positive ion. So aluminum's oxidation state is 3+ because it is in the 3rd group of the periodic table, so it's going to be 3+. And for it to become Al without any charge, you're going to have to add 3 electrons. So this will be your reduction. As you can see, it's following the same pattern. It's the exact same thing. The simple change is that copper requires 2 electrons to be gained, whereas aluminum requires 3 electrons to be gained, as this is in group 2 of the periodic table, and this is in group 3 of the periodic table. Complete the ionic equation for the reaction at the positive electrode. Now, your equation for oxygen and for the hydroxide ions, I highly recommend for you to memorize. The working behind both these equations is not required by IGCSE students. So you just need to know that 2O2 minus will give you O2 plus 4E minus. However, if it's easier for you to remember, here, if this is a positive electrode, so you are losing electrons, oxidation is happening. Okay, so if you are losing electrons, that means your stable form is giving away electrons to form an ion. So this is your stable form over here. And as you can see, it's 2O2 minus, so that makes 4. This is not the proper logic. I'm telling you that right now. This is simply for you to remember. It's basically a way for you to remember the equation, an easier way if memorization is too hard. So you are losing electrons. Your stable form is going to give away electrons. It's going to form the ion. You can see it's 2O2 minus, so there are 4 electrons that are being lost. Is the reaction endothermic or exothermic? Let's see. This decomposes. Always remember that a decomposition reaction is always endothermic. This I have discussed in the chemical energetics video. All decomposition reactions are endothermic, and that is because energy is supplied. Now, once again, they said explain your answer. So if you just say endothermic, you will not get your complete mark. You have to give a reasoning as to why it is endothermic, and that is because energy is supplied. The cells shown below can be used to determine the order of reactivity of metals. Is the reaction in the cell exothermic or endothermic? Now here you're going to have a reading of V because of the difference between the reactivity of the metals. And since there's a reading on V, that means that energy is being released because it is reading that energy, that amount of energy. Therefore, the reaction is exothermic. Energy released. Explain why the mass of magnesium electrode decreases and the mass of the copper electrode increases. So, this falls a little bit under your reactivity series. If anyone remembers the acronym that I had given. Sorry, not acronym, I meant mnemonic. It went something like, please stop calling me a careless okay, I can't write the entire thing, but it's basically, please stop calling me a careless zebra. Instead, try learning how copper saves gold. And each of the starting letters stand for the elements: potassium, sodium, calcium, magnesium, aluminium, carbon, and so on. You can search it up on Google. It's easily available. So here, if you look at your reactivity series, you will see that magnesium is more reactive than copper. So therefore, it tends to lose electrons. So magnesium, the more reactive, this is just a common fact in chemistry, the more reactive it is, the more it tends to lose electrons, the more it tends to undergo oxidation. So magnesium will be oxidized. Therefore, it is losing electrons, which makes sense as to why the mass is being decreased. And the ions are then, and the copper ions are deposited, or the copper ions are reduced. Now let me explain this a bit better. Okay. So here is our magnesium, and here's our copper. Right. Oh, we have it here. Okay. So, magnesium will tend to lose electrons. As it is more reactive, it is therefore the anode of the system. So, Mg2 plus, Mg2 plus, Mg2 plus, it's forming, it's going into the electrolyte, and the mass is decreasing. Copper is the cathode of the system because it is less reactive, and so the copper ions in the solution over here, they are gaining electrons, and when they gain electrons, they form the copper metal itself. Obviously, the stable form is there, and therefore the copper metal is deposited on this electrode, therefore increasing the mass. I'm going to try to re-explain this. Hopefully you can see better. All right, here we have our electrolyte, and we have Cu2 plus inside of it, and the ions are going to undergo reduction, so you're going to have an increase of, you're going to have it form copper itself, and since it's the copper metal, it is deposited on this electrode, increasing its mass. How would you use the cell to determine which is more reactive, magnesium or manganese? So a fact that you need to remember is the greater the difference between the reactivity between these two electrodes, the higher the reading on V. So let's suppose that magnesium and copper, this is a completely random value, okay, it's giving me 5V. Magnesium is more reactive than copper. There is a massive difference between magnesium and copper. If I replace this with zinc, the difference between zinc and copper on the reactivity series itself is less than the difference between magnesium and copper. The difference between zinc and copper on the reactivity series is less than the difference between magnesium and copper. Magnesium is coming somewhere here, zinc is somewhere here, and then we have copper. So this is more than what this is. Therefore, the reading is going to decrease. Now, how would you determine if manganese is more reactive or if magnesium is more reactive? Well, you're going to read the reading that it has for magnesium. So, let's see, how would you say this? Okay, record the voltage for magnesium and copper, right? Replace magnesium with manganese. If voltage decreases, then magnesium was more reactive. Or you could just say, actually no, it was more reactive. I was going to say that you could just say compare the two voltages, but that is way too vague. So you would record the voltage for magnesium and copper, and then you would replace magnesium with manganese. If the voltage decreases, if this decreases, that means the difference between manganese and copper is less than the difference between magnesium and copper, which means that manganese is falling on a lower scale in the reactivity series. Once again, you have Mg, Mn, and Cu. If our voltage is decreasing, that means that the distance between manganese and Cu is less than the distance between magnesium and copper, meaning that it is on a lower scale on the reactivity series. Obviously, you don't know which is more reactive it is very much possible you're not exactly sure if magnesium is more reactive or manganese is more reactive. So you could say if voltage increases, then manganese was more reactive. You could write this sentence over here and vice versa. It's fine. It's allowed. You're good. Okay. The combustion of propane is exothermic. Give an equation for the complete combustion of propane. All right. This compound itself falls under organic chemistry. However, I do believe in one of the videos that I did touch upon the combustion reactions to explain exothermic reactions, and therefore you should be able to write any combustion reaction that comes your way. So I will remind you that a combustion reaction always has the same products and never changes. It's always carbon dioxide plus water. And the meaning of combustion is being burned in the presence of oxygen. So you're obviously going to have oxygen as a reactant. And what is being burned in the presence of oxygen? Propane. Now, that is your 1 mark. Your 2nd mark is going to be for your balancing. So, I do believe I have covered balancing as well in one of the videos. I will make the reactant side, I will make the product side. C is equal to 3, H is equal to 8, and O is equal to 2. C is equal to 1 on the product side, H is equal to 2 on the product side, O is equal to 1. So we start our balancing. 3 into 2, 6 plus 1, 7 is what this has become. 4 into 2, 8. 4 into 2, 8. Whoa. And 4 plus 6. 3 into 2 is 6 plus 4. That's the amount of oxygen. We have 10. So we got 3 and 3. We got 8 and 8, but we have 2 and 10. So 5 over here to 2 gives 10. 3 and 3, 8 and 8, 10 and 10. And that is your balanced equation. The rest of this is not something we have covered so far. Okay. I skipped that as well because it's not part of what we've done. Zinc can be obtained from zinc oxide in a 2-step process. Aqueous zinc sulfate is made from zinc oxide, and then the solution is electrolyzed with inert electrodes, inert meaning unreactive. The electrolysis is similar to that of copper to sulfate with inert electrodes. Name the reagent which will react with zinc oxide to form zinc sulfate. This is not part of what we've done so far. It's going to occur. We're going to cover this in our next video, acid, base, and salt. But basically, sulfuric acid will react with zinc oxide to find zinc sulfate, but we're not going to write that. Okay, complete the following for electrolysis of aqueous zinc sulfate. Aqueous zinc sulfate. So I'm just going to quickly make that table that we covered in the electrolysis video in case we need it. At the negative electrode at your cathode, the first thing you guys just need to do immediately is cross this out. Spectator ions never take part in the reaction. So the negative electrode is the cathode, and opposites attract. That means that one of the positive ions, a cation, is going to go to the cathode. Now, which one is less reactive between these two? Because the less reactive is the one that goes forward. That would be hydrogen. So our equation, our half equation will be... Oh, wait. Okay, so they tricked us over here. Very important. Here, although that would be the actual working of the electrolysis, they have told us here the electrolysis is similar to that of copper to sulfate. Copper to sulfate. Very, very important. And the thing with copper to sulfate is that, one second, okay. As copper is less reactive than hydrogen, copper 2 plus is the one that goes forward to cathode. not hydrogen, because copper is under hydrogen in the reactivity series, and the less reactive one is the one that goes forward for the ionization and electrolysis. Copper is the one that would go forward. And since we're following the same working as copper 2 sulfate, because they have specified that in the question, we will assume that zinc will be doing the same thing. So let's write the reduction reaction. We have the ion Zn2 plus. It is gaining its 2 electrons, and therefore it is forming the zinc metal. So name the product at the positive electrode, the product. Be careful. Again, sulfate ion never ever ever takes part in the reaction. So you're going to have hydroxide go forward to anode, which is your positive electrode. And hydroxide forms the product oxygen. Remember, do not write hydroxide over here in this answer. The only appropriate answer is that oxygen is formed, because hydroxide forms oxygen. The electrolyte changes from zinc sulfate to, so let's see, zinc is gone, hydroxide is gone. So the only 2 ions that we have left are H plus and SO4 2 minus. And that is basically going to form, if you do your cross multiplication, your formulas. The charge is 2, so 2 here, the charge is 1 here, H2SO4. Basically, this is sulfuric acid, so it's forming sulfuric acid, or you could write hydrogen sulfate. We will cover acids in great detail in the next chapter. Right, a dry cell battery has a central rod, usually made of graphite. This is a positive electrode, which is surrounded by the electrolyte. Typically a paste of ammonium chloride and manganese oxide, all of which are in the zinc container, which is a negative electrode. Electrons flow when cell produces energy. This is the wire, graphite electrode, zinc electrode, electrolyte. Draw an arrow on the diagram to indicate the direction of the electron flow. Right, so your electrons will be flowing this side. Clockwise, yes, because zinc is more reactive, it tends to lose its electrons, and therefore this is how your electron flow will be. Suggest why the electrolyte is a paste. An electrolyte always has to be something liquid, something molten, because you need the ions to flow, you need it to be movement, because that is the only way that charge is carried. How is a conductor of electricity? Because it has free moving electrons and they can carry the charge. So therefore, the electrolyte is a paste to allow ions to flow. The following changes occur in a dry cell. For each change, decide if the oxidation or reduction and give the reason for your choice. So from Zn is becoming Zn2 plus, which means that 2 ions were lost. 2 plus means 2 ions were lost. 2 minus would mean that 2 ions were gained, because the more negative charge that is gained, the higher the negative number. That's how it works on ions. So if you're losing ions, then it's going to become a more positive charge, because the negative charge is leaving. Although I'm pretty sure most of you know this information by now. So this is oxidation due to loss of electrons. They told you to give a reason for your choice. Now manganese number 5, oxide to manganese number 3. I mean, you don't read it like that, obviously, but I'm writing the Roman numbers, the Roman numerals in the normal form. What do you call them? Okay, so here, this, for your information, is the oxidation state. These numbers represent the oxidation state. And since the oxidation state is decreasing, this is reduction. So there are 3 ways to determine your oxidation and reduction. Your first is loss or gain of electrons. This you saw over here. This is your first way to determine oxidation or reduction. You can see that the loss of electrons is happening here. Therefore, it is oxidation. I'm just going to write oil rig over here. Okay, oxidation is loss of electrons, reduction is gain of electrons. Your second method is change in oxidation state. And that is that a decrease in oxidation state is equal to reduction, and an increase in oxidation state is called oxidation. Your third method of determining reduction or oxidation is the element oxygen. Basically, loss or gain of oxygen. For example, C plus O2 gives CO2, so carbon was oxidized because it gained oxygen. So your 3 ways of determining loss or gain of electrons, determining oxidation or reduction. This is very important because your MCQs asks you to determine oxidation and reduction, and as you can see, there have been many times where we had to determine that in the electrolysis questions here, or write a reduction or oxidation equation. Not part of what we've covered so far just yet. Alright, the reaction between methane and oxygen can also form carbon dioxide. How can carbon monoxide be made instead of carbon dioxide? We have discussed this in one of the past videos. And anything monoxide is because of the incomplete combustion of that element. So the incomplete combustion is the reason why carbon monoxide is formed. Incomplete combustion is why nitrogen monoxide would be formed. The following reaction is used to make carbon monoxide and hydrogen. The reaction is reversible and comes to equilibrium. Suggest why a high temperature is used. You have 2 marks here. We have covered this before, so I will be answering it. First of all, immediately when there are 2 marks and it's a factor of a rate of reaction, you write it right then and there. Why high temperatures used? Because high temperatures cause faster rate of reaction. Your reaction will be faster. And secondly, since they have told you that, now they have not given you any means of knowing if this is an exothermic or endothermic reaction. However, in the question, they have very straightforwardly said that high temperature is used. They're just asking you why. They're like, so just why a high temperature is used. So the only reason that a high temperature would be used, other than that it's faster, is because your forward reaction is endothermic. And therefore, is favored by high temps increasing yield. Now again, in our given, they did not tell us if it's endothermic or exothermic. They did not give us delta H. But here they just said suggest why a high temperature is used. So you know for a fact that it is a high temperature, and there are 2 marks. And that means that your reaction rate answer cannot be enough. So obviously that would mean you would just have to use your process of elimination or your common sense, I guess, over here, that it's obvious that the forward reaction would have to be endothermic if they are using high temperatures, and therefore your forward reaction is going to be favored, increasing your yield. What is the disadvantage of using high temperature for the reaction given in part 2? So let's look at the number of moles on each side. We have 2 here and we have 4 here. And increase in pressure favors the side with smaller number of moles. It's going to move to that side. Therefore, your yield, the amount of product is going to decrease. So, high pressure favors side with small number of moles, or smaller comparatively, smaller number of moles, which is the left hand side, decreasing product yield. Alright, chlorine is made by the electrolysis of concentrated aqueous sodium chloride. Describe this electrolysis. Write ionic equations for the reaction at the electrodes and name the sodium compound form. This is worth 5 marks. You need to make sure you are addressing all of these points, that you're writing ionic equations for the cathode and the anode, and you're naming the sodium compound formed. Okay, so let's describe the electrolysis. First of all, I'm going to give you the working of it itself. We have aqueous sodium chloride. Since it is concentrated, your chlorine will take part in the reaction. And as it is an anion, it is the negative ion. It's going to go to the positive electrode. It's going to go to anode. And between these two, hydrogen is less reactive, so it goes to cathode. So, we can start off with saying that as the solution is concentrated, chlorine gas, you could write chlorine gas, or you could just write CO2, is formed at anode. Then you can write between the two cations, H plus is less reactive, forming hydrogen gas, or I'm just going to write H2, at the cathode. Right. The compound formed I'm just going to go down there for you to see. If Cl is gone and H plus is gone, then you are left with NaOH, which is sodium hydroxide. So the compound formed as a result of the two ions left behind is sodium hydroxide. So you have 1 mark for the mention of chlorine being formed as a product. You have your 2nd mark for a mention of hydrogen gas being formed as your other product. Then your 3rd mark is for this point right here. Name the sodium compound formed. I have done that. That's 3 out of 5. Now your final 2 marks is going to be the ionic equations of the reactions at each electrode. So cathode. What do we have forming at the cathode? We have hydrogen forming. So 2H plus 2E minus gives H2. This is the reduction reaction. H2 is your product, which means that you're gaining, you got H2 is your product, H plus is your ion. 2 electrons are being gained, so make sure to balance it. And your anode, you have chlorine being formed. So chlorine gives Cl2 plus 2E minus. This is the reaction that would occur at anode. 2Cl minus, yeah. Your ion is losing electrons. Yeah, so your chlorine is losing electrons to form this ion. That is how your equation looks like. Or to make it easier for you guys, because you are technically forming the chlorine product and that's what you need to show, you could do 2Cl minus 2E gives Cl2. There we go. So this is your 4th mark, and this is your 5th mark, and that is your entire 5. Not done yet. Moving on. Okay. Although I'm unsure of if I have covered this in our electrolysis video, I don't think I have, so I'm going to do it here. So this is very, very important. This is 6 marks. So let me just explain the entire concept to you before writing the answer itself. So describe the extraction of aluminum for alumina. So the electrolyte is going to be alumina, obviously, and this is going to be dissolved in molten cryolite. Now, usually there are a lot of questions in IGCSE, and the question is 2 marks as to why, or 3 marks, why you dissolve alumina in molten cryolite. And the reason behind that is because it decreases the operating temperature. So it's usually 2 marks, right? I remember operating temperature. And it increases the conductivity. Now, it's usually 2 marks, but if they do it for 3, then it's basically the base. Your 3rd point is going to be the base of this point, and that's allowing ions to move, basically free moving ions, and that is how conductivity occurs. So molten cryolite is used to decrease the operating temperature and increase the conductivity of the system. And other than that, when you dissolve the cryolite, obviously, since this is electrolysis, you're going to need electrodes, and your electrodes are going to be graphite because they are inert and they have good conductivity. And you will then have aluminum forming at cathode, and your oxygen forming at anode, which is just what you can deduce from the fact that you are extracting aluminum from aluminum oxide. And your last point that you need to know for the extraction of aluminum by electrolysis is that the anode, okay, this is an important point. Instead of graphite, although graphite is correct, how you technically, for the extraction of aluminum, you make your electrodes carbon. Graphite is a form of carbon, isn't it? So for the answers to these questions, make sure you write that the electrodes are carbon. And basically what happens is that as at the anode you have, okay, I'm going to make the anode here. All right. This is your carbon anode. And what's happening here is that oxygen is forming, right? And so the carbon anode is burning in the presence of oxygen, and this releases carbon dioxide. So basically, this is why you're going to have to replace the anode periodically because it's getting burned in the presence of oxygen. It's decreasing its mass. It's getting burned because of oxygen and releasing carbon dioxide. So this is one important point that you need to remember for the extraction of aluminum. So you're going to start off with alumina is dissolved in cryolite, molten cryolite. This is 6 marks, so do not leave anything that is occurring in your brain. Write it all. There is no negative marking in IGCSE, so do not take negative chances. Just go for it. If it's wrong, you're not going to lose mark. If it's right, then you're going to gain those marks. So go for whatever's coming in your head. Alumina is dissolved in molten cryolite, and then you will write the benefit of cryolite. Molten cryolite reduces working temperature and increases conductivity. The electrodes used are carbon as they're inert. Aluminium will be formed at cathode. Guys, remember aluminium is 3+. This is a positive ion, so we'll go to the negative electrode because opposites attract. So it's formed at cathode, and oxygen is formed at anode. And then you will write that the anode needs to be changed periodically as it is burned in the presence of oxygen, forming CO2. So all of this detail is what will give you your 6 marks. Thickness, oxide, this is details from another chapter. Anodizing is an electrolytic process. The dilute sulfuric acid is electrolyzed with an aluminium object as the anode. The thickness of the oxide layer is increased. Complete the equation. So really all of the information that they gave us was absolutely useless. And what you need to know are your half reactions. I have told you, memorize the reaction for hydroxide. It's always going to remain the same because it's the negative ion. It's always going to go to the positive electrode, and it's always going to have the same oxidation occur for it. And over here, you can see that this is not a half equation. There is no concept of electrons anywhere. So you need to write a proper equation. You are forming aluminium oxide, which means that one reactant is oxygen itself. Now the rest of it is just balancing. You have your reactant side, you have your product side. Al so far is 1, O so far is 2, Al is 2 over here, and O is 3 over here. So we set out to balance. Okay, great. But the thing is that this needs to balance out as well. How could you do that? We could put 2 here, because that would make it one way to determine which one you're going to attack first, which one you're going to change first, is try to change the odd number to an even number. Try to go for the odd number and try to change it to an even number, okay? So I don't want to touch this because this is even. This is annoying me, so I'm going to put 2 here, make this 6. That will make this 4. So that means I'm going to have to change this to 4. And this needs to balance this, which means that this has to be 6 and 4, 4, 6, 6. Balance, boom, 4 marks. Easy. Okay. At the present, the most important method of manufacturing hydrogen is steam. Okay. Useless information. Right. In the first stage, the process methane reacts with steam at 800 degrees Celsius. In the second stage of the process, carbon monoxide reacts with steam at 200 degrees Celsius. Explain why. The position of equilibrium in the first process is affected by pressure, but the position of equilibrium in the second process is not. Number of moles, number of moles, number of moles, and number of moles. So simply the number of moles in the first reaction is different. Whereas the number of moles in the second reaction is equal. So this is why high temperature is needed for the first reaction to get a high yield of products, but in the second reaction, high yield is obtained at a low temperature. So this right here, okay, first of all, your temperatures are an indication itself. However, actually, let's not look at that. Let's look here. They've already told you that to get a high yield, there's high temperature. To get a high yield in the second reaction, there's low temperature. They're just asking you for the reasoning as to why this is. They have implicitly already established the fact that the first reaction will have a high yield at high temperature. And when does that happen? When the forward reaction is endothermic. In the first reaction. Handwriting is really giving up, so Okay. And in the second reaction, you're getting high yield with a low temperature, and that happens when you have an exothermic reaction. In the second reaction is exothermic. Okay, moving on. This is not part, this is organic chemistry. There are three types, there are three products of electrolysis and concentrated aqueous sodium chloride. Hydrogen is one of them. Write the equation of the electrode reaction that forms hydrogen. So hydrogen is H+, which means that it goes to the cathode, which means that it undergoes reduction. So honestly, you guys, the amount of times you are going to need to write the hydrogen half reaction while practicing past papers for IGCSE chemistry, you will have this equation memorized. You will know it as the back of your hand, so don't worry about it. Name the other two products in the electrolysis. I already explained the concept to you. Make your table. OH minus, it's concentrated, so you get chlorine. You know hydrogen is going, what's left behind is the sodium hydroxide. So product is sodium hydroxide. It can be used for soap. This is the type of thing that you will learn just from past paper practice, because it's not a fact that you might find in your book or in your notes, or it's something you might honestly overlook, because who really cares what sodium hydroxide does? But when it comes as a past paper question, you look at the marking scheme, you learn. So again, maximum past paper practice, very helpful. And the second is chlorine, and that is bleach. There are other uses as well. Sodium hydroxide of in soap is for paper, detergents, paint, stripper, clearing drains. Chlorine is used for water treatment, very important, disinfectants, bleach, I already wrote that. Pharmaceuticals as well, pesticides, a lot of different stuff. Whatever is easier for you to remember, easiest for you to remember, just write that down. I told you they do ask why you use molten chloride. It conducts either when molten or when dissolved in molten cryolite. Explain why. Because you have free moving ions. That is your actual answer. Why is it in molten cryolite? Because you have free moving ions. However, this is 2 marks, and in the first part of the question, they have stated that solid aluminum oxide is a poor conductor of electricity. So when they say explain why, you have to explain why is a poor conductor as a solid and why it is a good conductor when it is molten. So ions cannot move in solid state. However, they move freely in molten or liquid state, allowing conductivity. Why is a solution of aluminum oxide in molten cryolite used rather than molten aluminum oxide? Now that comes to the benefits of molten cryolite, which I have already told you there are 2. This is only 1 mark. You can write either of them. You can either write that reduces the operating temperature, or better conductor when dissolved in cryolite. Now, if I were you, I would lean to this one in case there's confusion as to why, because molten also has free-moving ions, therefore it also conducts electricity, but there's the whole working of the fact that it's dissolved in cryolite in another compound and blah blah blah. Not needed, irrelevant information. You could write better conductor when dissolved in cryolite as well. It's your choice, but personally I would be able to remember more that reduces operating temperature as a point. So, okay, explain why carbon anodes need to be replaced periodically. We also just covered this, and that is because they burn away in the presence of oxygen, forming CO2. Forming CO2. One reason why graphite is used for the electrodes is that it is a good conductor of electricity. Given another reason, it's because it is inert, unreactive, does not take part in the reaction. Aluminum is used, okay, this is the uses and the properties of the metal that it is, which is not part of your syllabus. So I'm going to end this here. I feel like we have covered quite the amount of questions, covered a few of the small implicit concepts that come with electrolysis as well. I hope this was helpful. If you have any questions, comment them down below. If there is a certain past paper session for a certain topic that you want me to do as soon as possible, let me know and I will look into it. And yeah, I hope this helps.